Hi everyone, this is Mrs. Snowback. Today we are going to cover Unit 8, Lesson 4. We're going to learn how to find areas of irregular regions and also areas of composite figures. Imagine if it was your job way back when they were settling the United States back in the early 1800s. Imagine if it was your job to figure out the area of Minnesota. That would have been kind of hard. There were no satellites, there were no airplanes, there might have been some hot air balloons, but I think that would have been maybe the only thing that could have gone up above the United States to kind of look at the land. So think about the state of Minnesota. Why does it have some of the boundaries that it has? Why is it such an odd shape? Well, oftentimes the states were given their boundaries based on rivers, mountainous regions, different landscapes that kind of helped divide the two states. For instance, the Mississippi River starts up here somewhere and kind of goes like this, all the way down to the Gulf of Mexico. And so a lot of the states along the Mississippi have their crazy borders because of the way that the river winds. So I don't know if you remember this from history class, but Minnesota became a state in 1858. Not that you really need to know that for math class, but as they settled the state of Minnesota, the most populous region was the Twin Cities around St. Paul. That became the capital of the state, of course. And you can see the region around the Twin Cities got divided up into these little squares, into grid lines. So this is a very early map of Minnesota. It looks like they also kind of explored along the North Shore and divided that into grid lines, but much of the upper part of the state had not been explored yet. Here's another map of Minnesota. This is years later, and you can see more of the map has been gridded off. Why would they grid off the map? Well, the reason they did that is because it made it easier to find the area of things. If you knew how big your grid lines were, maybe they were 20 miles by 20 miles, then you could figure out the area of Minnesota based on how many squares you had within the state's boundaries. Here's a picture of another old map. You can see Minnesota has been made a state, but the North Dakota and South Dakota states have not been officially formed yet. They're still territories, the Dakota Territory. And so, again, they're taking that map and they're dividing it into grid lines. I don't know if you can see it very well on Minnesota there, and they're breaking it up into little sections. How did they measure off those sections? Well, they didn't have satellites, right? So they probably had to step them off. Maybe they had ropes that were a certain length, and so one person would hang on to one end of the rope, the other would walk. They'd put a stake in the ground at the end of the rope, and they'd kind of step off or rope off different distances until they had the length that they wanted. I'm not sure if you've learned about the Homestead Act, but back in the 1850s, 1860s, 1870s, when people were coming to Minnesota and settling and creating farms, there was this thing called the Homestead Act. And so, I think about if you've ever watched Little House on the Prairie or read any of the Little House on the Prairie books, Pa Ingalls packed up his family and traveled from Wisconsin over into Minnesota. He traveled from the big woods into the prairies of Minnesota. And he came to a little town in the show, it's Walnut Grove, and he came to Walnut Grove and he saw this land that was available still. He probably went to the store in town and saw the land plots, and there was a plot out by a stream that was still available. So he went out there, checked it out, and then he said, yeah, this is a good place. And so let's talk about the Homestead Act a little bit. The Homestead Act was passed on May 20th, 1862, and it accelerated the settlement of the Western Territory by giving adults 160 acres of land for a minimal fee. And what they had to do is they had to live there for 5 years continuously, and they had to develop the land or improve the land. So they had to build a dwelling on it. They had to cultivate the land, which oftentimes meant cutting down the forest and making fields. And it was a very small fee to do this, just a little registration fee. And if they could farm the land and show improvement over that 5-year period, they got the land for free. And so that's the Homestead Act, which, for better or worse, that's what happened in history. Here's an example of the city of Farmington back in the late 1800s, and you can see the homesteaded pieces of land that have been parceled off. The names of the families that got these pieces of land are on them. You can see how many acres. I believe this says 320, so that would have been 2 homesteads. Some of them say 160. Some of them say 80. It's a little blurry and hard to read, but you can see they have gridded off the land and made them into homesteading pieces. All right, so let's get into section 8.4 and how did they find the area of irregular regions and how could we still do it today? Think about the state of Minnesota, or think about a lake, like maybe Lake Mille Lacs. You wanted to find the area of that. As the settlers came in, they thought, wow, this is a huge lake. Let's find the area of that so we can map out the state, and they'd have to draw the map, right? So here's an example. There's going to be 4 steps, and step number 1, you can see right up here, is you're going to count the number of full squares within the boundary. So number 1, it says find the area of the lake below. So we're going to look on here, and I think I'm going to put dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Should I count that last one as a full square or not? I'm gonna say not. It's kind of a judgment call though. So I'm gonna say I had 28 full squares. Step number 2 up at the top here, it's count the number of partial squares and divide by 2. So now I'm going to look at the boundary, and anything that's partially within the boundary, I'm going to count. So I'm going to put tick marks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I'm going to go with there's 24 partial squares. And then we're supposed to divide that by 2. So divide that by 2 and we get 12. Why don't you take a minute and pause the video and you practice. Count the full squares and count the partial squares and see if you get the same numbers I got. All right, step number 3. Now we're going to add the numbers from parts 1 and 2 together. So we're going to take 28 and 12, and we're going to add 28 plus 12. And let's see here, it looks like we get 40. And then step number 4 is we are going to multiply by the area of 1 square. So if you go back to the instructions here, it says each square is 2 miles in length. So think about one of these squares up here. That means it's going to be 2 miles by 2 miles. So what's the area of the square? It's 4. 2 times 2. So for step number 4, we're going to take our answer from number 3, 40, and we are going to multiply by the area of 1 square, which is 4. And it ends up being 160, and our label would be miles squared. So the area of this particular lake would be 160 square miles. I did look up, by the way, the area of Lake Mille Lacs. It is 207. Mille Lacs is 207 square miles. So this lake is smaller than Lake Mille Lacs, but still a pretty big lake to be 160 square miles. All right, well, you guys try this one. Pause the video, count the number of full squares, count the number of partial squares, and then we'll compare our numbers. So when I counted, I kind of went back and forth about a lot of them, but I decided to count this one. So 1, 2, 3, 4, 5, 6, And then I thought about that last one. If you counted that last one, I can see why I decided to stick with 6. It looked like a little smidge of a corner was cut off of that one. So I had 6 fulls, but if you had 7 fulls, I can understand that. Then I counted the partials. So I'm just going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think I get 15 partials. So 15 partials. Again, I'll give you a little bit of leeway. Like if you have 14 or 16, I would probably give you full credit on there. Divide that partial by 2. So 15 divided by 2 is 7.5. Next, we're going to take our fulls plus half our partials. Because why do we take half the partials? Because on average, they're going to fill up to be, every 2 partials will make 1 full square on average. So we're going to add 6 plus 7.5, which is 13.5. And now we have to multiply by that by the area of each square. Up here, it says each square measures 0.25 miles in length. So each square is 0.25 by 0.25. If you multiply that, the area, 0.25, times 0.25 is actually 0.0625. So that's going to be the area of 1 square. So for step 4, we're going to take 13.5 and we're going to multiply by 0.0625. And we get 0.84 miles squared. So my question to you is, if this is a lake, would it be big enough to ski on? Could you water ski on this lake? Or could you tube on this lake? It's 0.84 square miles. So think about what that means. Let's say we had a rectangle. And let's say our rectangle was 1 mile by 0.84 miles. If you multiply base times height, you'd get 0.84 miles squared. Could you water ski or tube on a lake that's 1 mile long by almost a mile wide? Yeah, for sure you could. For sure you could. We do this all the time at our lake. Our lake is only a mile long. It's plenty big for several boats to be out tubing and skiing at the same time. The second part of our lesson today is we're going to find areas of composite figures. And a composite figure is a figure that can be separated into regions that are basic geometric shapes. For instance, take a look at number 1 here. We're going to learn how to find an area of this shape. This is not a parallelogram. It is not a trapezoid. It's not a kite. It's not a circle. But if we divide the shape up into 2 shapes, now we do have 2 shapes that we know the area formulas for. On the left, on this side, we have a rectangle. And on the right, we have a trapezoid. And we know the formulas for each of those. So if you divide it up into shapes you know, and then find the area separately, and then at the end add them together, you should get the total area. So let's start with the rectangle on the left. The formula for area of a rectangle is base times height. Do we know the base and the height of that rectangle? We sure do. We can say the base is 8 and the height is 12. So 8 times 12 is 96, and so the area of the rectangular part on the left is 96 inches squared. And then the area of a trapezoid formula, remember for a trapezoid, the formula is a little trickier. It's height times base 1 plus base 2, divide by 2. So let's think about, do we have all of the measurements that we need? Well, probably not quite all of them. So I think the 2 bases are these 2 sides that are parallel to each other. Let me give them a little like green, those 2 green things. Those are the bases. So I can see one of the bases over here is 5, but I need to know this other base right here. But if you slide this 12 over, wouldn't this also be 12? So bases are 5 and 12. And then the height. The height is going to be this distance right here, the distance between those bases. Well, at the top we have an 8 inches. At the bottom we have 15 inches. So if we slide that 8 down to here, we should be able to do 15 minus 8, which is 7, and we can figure out the height down here is 7. So it's going to be 7 for the height of the trapezoid, the distance between the bases, and then the bases themselves are 5 and 12, and then divide by 2. And then you type that in your calculator, and I think it's 59.5. And then to get the total area of the whole composite figure, you have to add the rectangle and the trapezoid. So at the end, the total is going to be 96 plus 59.5. which is 155.5 inches squared. Number 2, find the area of the shaded region below. Note the frame has the same width of 25 feet on all sides. So we're going to try to find the area of just the shaded part. I'm thinking we need to take the area of the big rectangle, which is like this whole area as if it was all filled in, and then find the area of this little rectangle and subtract the little one out, kind of like taking out a donut hole. So let's find the area of the large rectangle. And remember, rectangles are base times height. So we need the base all the way across the rectangle. And it said the width is going to be the same on both sides, so I think this is also going to be 25. So this part is 25, this part is 100, and this part is 25. So that whole distance across there is going to be 150. Now let's think about the height. So again, let me just grab a different color here. I'll grab green. So this is 25, this is 20, and this is 25. So think about what's 25 plus 20 plus 25. I think this whole distance is 70. So if I want the area of the large rectangle, it's going to be 150 times 70. So the large one is 10,500. Now I'm going to find the area of the small rectangle. The area of the small rectangle is going to be 100 times 20. 100 times 20 for the small one is 2,000. So now, how do we get just the shaded area? You're going to have to subtract. So you're going to take 10,500 minus 2,000. Subtract out that rectangle in the middle, and you'll have 8,500, and this is going to be feet squared. So this is your answer for part A. For part B, find the probability of landing in that shaded region. Do you remember how we did this? The probability part, you go the shaded region divided by the total region. So in this case, we're going to take 8,500, which is the shaded region, and divide by 10,500, which is the total area of the whole big rectangle. When I divide those, I get 0.8095. Move the decimal over 2 spots. It's 80.95% chance of landing in the shaded region. An area for a semicircle, well, a whole circle is pi r squared, so just divide that by 2 and you should get a semicircle. So in this case, it's pi, and then the radius of that circle is right here, so it's 4 squared, and then divide by 2. So that should end up approximately as 25.13. Next, I'm going to do the triangle. So for the triangle, area of the triangle, it's base times height divided by 2. Now this one's a little trickier. We have to do a little extra work. We know this would be a 90-degree corner right here. I think that might even be on your sheet. If not, draw it in. And then I see one side here is 4, but we need to find this other side so that one is the base and one is the height. We need the two that meet at 90 degrees. So I'm going to have to use this triangle and do a little Pythagorean theorem to figure out x. So 4 squared plus x squared equals 5.7 squared. And when I do that, let's just figure out what's 5.7 squared, 32.49. Subtract your 16, and you get x squared equals 16.49, and then take the square root, and it ended up being 4.06. So this little distance right in here is 4.06. But that's going to allow us to find the area of the triangle. It's going to be 4 times 4.06 divided by 2. Base times height divided by 2. This ends up being approximately 8.12. Last but not least, we have the rectangle. And so for the area of the rectangle, it's just base times height. And I think there we can just use the 4 and the 7. So 4 times 7, 28. Awesome. Now we can take our 3 areas and add them together. So we're going to add 25.13 plus 8.12 plus 28. And our area ends up being approximately 61.25. And it's going to be feet squared. All right, last one. Will you please pause the video and see if you can do number 4? So we need to do a little work here. I'm going to divide this into a semicircle and a trapezoid. So the semicircle is over on the right and the trapezoid is on the left. But I need to know the radius of the circle, halfway across the circle. So I'm going to drop this down right here. The distance from this point to this point is 22, and the distance from this point to this point is 31. 31 take away 22 is 9. So this distance right here is 9. This is going to be a right angle, and I'm going to do Pythagorean theorem to get this height. I'll call it h. So I'm going to do 9 squared plus h squared equals 15 squared. I'm using this triangle over here on the left. So we have 81 plus h squared equals 225. Subtract your 81. H squared ends up being 144. Haha, this is going to be a nice number. It's 12. So I'm just going to erase this h, maybe erase this h, and it is 12 here. That's awesome because that means over by the circle it's also 12, but I'm going to divide it into a 6 and a 6. So now here we go. We're going to do, first of all, the area of the semicircle. Remember, circles are pi r squared, and then we're just going to divide it by 2. So it's going to be pi 6 squared divided by 2. That ends up being about 56.5. Then we're going to do the trapezoid. So area for a trapezoid is going to be height times base 1 plus base 2 divided by 2. We know the height. Here it is, 12. The bases are the 22 and the 31. So here's one base, here's the other base. You do not have to include the 9. That was already included in the 31. And then divide by 2. So that ends up being 318. Final step, add your two amounts together. So 56.5 plus 318, the total area is 374.5, and it's going to be centimeters squared. Wow, that was a long one. Hopefully you made it through without falling asleep. Will you please try Unit 8, Practice 4? If you need help, let me know. Have a good one.